Bismillahirrahmanirrahim. Assalamu alaikum. I am Abdullah Noor. Today our topic is work. In this video we are going to discuss definition of work, formulas for work done, do experiment to clear the concept of work done, some cases of work done, and in last, real life example. I am sure by the end of this video the concept of work will really clear to you. Now what comes to your mind when you hear the word work? Are you thinking about your homework? Sometimes we mean exercise, or we mean a place where we go every day and do something to earn money. For me, work today is to make a video for you. The physics definition of work is very different from our everyday use of the word work. Now move toward definition of work done. Definition of work done is based on two things. First one is force and the other one is displacement. So the definition is: work is done when a force acting on a body displaces it in the direction of a force. The formula to calculate work done is force into displacement in the direction of force. And the SI unit of work is joule, which is represented by capital J, and joule is defined as the amount of work is 1 joule when a force of 1 Newton displaces a body through 1 meter in the direction of force. To understand this, let's do a simple experiment together. For that, I need you to get an object like a book. So pause the video right here and go and get a book. So, are you ready with your book? If you are holding a book, now the question is, are you doing any work right now? The answer is no, because there is no displacement of the book. But if you lift up the book like this, have you done any work? No. The answer is yes, because there is force involved and there is a displacement. You can feel the force. When you are lifting the book and your book displaces from one point to another. Here we have a wooden block. So if I pull a block like this, I'm doing work. As you can see, force and displacement are in the same direction here. Now an interesting question. Is it possible that force and displacement are not in the same direction? What do you think? The answer is yes. Let me show you. So suppose if I now pull the block like this. As you can see, my force is along the string, but the displacement is along the x-axis. There is an angle theta between the force and the displacement. Now How do we calculate the work done for this case? As we saw here, force is along the string and the displacement is along x-axis, but we want to calculate the force in the direction of displacement. So for that, consider a right angled triangle here. Theta is the angle between the force and displacement. So as you can see, the force along the hypotenuse of the triangle, but we are interested in finding the force along the displacement or along the base of the right angle triangle. So what will be the component of the force along the base? That's right, it's going to be force F into cos theta. So what will be the work done here? It became work done equals to force cos theta into displacement. As we know, F cos theta is the x component of force. And now simplify, the work done became Fd cos of theta. Now move toward some cases. Case number 1. When angle is 0 degree, it means that the force and the displacement is in the same direction. The formula is work done equals to Fd cos of theta. We put angle equals to 0 degree. As we know, cos 0 is equals to 1. So the work done became Fd. In this case, maximum work is done. Now move toward case number 2. In case number 2, angle is equals to 90 degree between force and displacement. The formula is W equals to Fd cos of theta. As we know, cos 90 equals to 0, so the work done became 0. Case number 3. When angle is 180 degree. For this, the formula for work done is Fd cos of theta. Put the angle. As we know, cos 180 equals to minus 1. In this case, the work is maximum but in opposite direction. Real life example. A girl carrying a 10 kilogram bag upstairs to height of 18 steps, each 20 centimeter height. Calculate the amount of work done she has done to carry the bag. Solution. Mass of the bag is 10 kilogram. Weight equals to mg, and weight is basically force. In this case, mass is 10 kilogram. Multiply with the value of g. The force became 100 Newton. To carry the bag upstairs, the girl exerted an upward force F equal to weight, the weight of the bag. Thus, force became 100 Newton. Height equals to 18 multiplied by 0.2 meter. Because 20 centimeter is not in SI unit, we convert 20 centimeter in SI unit, it became 0.2 meter. Then put the values. The girl has done 360 joule of work. Thank you so much for your patience. Allah Hafiz.